Italy's strategic bet on the Global Combat Air Program marks a profound shift in how Rome positions itself in the future of air power, industrial capability, and alliance politics. While the program is often framed as a partnership between the United Kingdom, Italy, and Japan, the deeper reality is that Italy has quietly emerged as the backbone of the program's sensor and electronic architecture. This outcome is neither accidental nor symbolic. It reflects decades of accumulated expertise, a unique industrial ecosystem, and the country's unusual diplomatic position bridging Europe and the Indo-Pacific. Understanding Italy's role in GCAP is essential to understanding how the next generation of air combat will be shaped across multiple regions. Italy brings a rare combination of operational experience, industrial specialization, and technological maturity in radar and sensor fusion. Leonardo, Italy's flagship defense company, has been a major supplier of advanced radars and avionics across NATO for decades. Systems such as the Captor-M and Captor-E radars for the Typhoon, the Kronos family of multifunction radars, and the Osprey active electronically scanned array radar have built a record of reliability and adaptability. This history matters because sixth-generation combat aircraft will rely less on raw aerodynamic performance and more on the integration and fusion of distributed sensors. Italy, unlike many mid-sized powers, does not simply buy sensors. It builds them, maintains them, and integrates them into multinational projects. Another factor strengthening Italy's position within GCAP is its industrial participation in the F-35 program. The final assembly and checkout facility at Cameri has given Italy experience with sensitive systems integration, stealth manufacturing protocols, and sensor alignment processes that only a handful of countries possess. This exposure adds credibility when Italy argues that it should lead the sensor fusion pillar of GCAP. Few partners can match Italy's ability to harmonize data from radar, infrared search and track systems, electronic support measures, and passive detection sources into a coherent tactical picture. GCAP's ambition to operate as a system of systems, cooperating with drones, satellites, and ground-based assets, depends on precisely the type of architecture that Italy specializes in. Diplomatically, Italy occupies a unique middle ground between its partners. The United Kingdom carries historical leadership in combat aviation and deep links to the United States. Japan brings industrial rigor and capital, but is new to multinational, sixth-generation ventures. Italy fills the connective tissue between these two models. Italian companies have long experience cooperating with the United States, the United Kingdom, and continental Europe, while simultaneously maintaining an export tradition that spans the Middle East, North Africa, and Asia. This flexibility allows Italy to act as an intermediary, ensuring that the program remains interoperable, exportable, and not dominated by any single national doctrine. Italy's technological contributions to GCAP begin with the future radar system that will exceed the performance of today's Captor-E. The new radar will likely operate across multiple frequency bands, combining the power of traditional X-band arrays with the stealth detection advantages of lower frequencies. Multi-band radar, combined with rapid beam steering and electronic attack capabilities, is expected to make GCAP a dominant platform in counter-unmanned aerial system operations and high-intensity air-to-air engagements. These technologies are not theoretical. Leonardo has already demonstrated multifunction arrays that blend radar, communications, and electronic warfare onto a single aperture, a feature considered essential for sixth-generation survivability. Beyond active sensors, Italy is also set to shape the passive detection environment of GCAP. Electronica, a leader in electronic warfare, is developing new generations of electronic support measures capable of identifying, classifying, and geolocating threats with minimal electromagnetic exposure. In an era where emissions can reveal aircraft positions, passive detection becomes central to survival. Italy's experience integrating electronic warfare systems on the Typhoon, the Tornado, and naval platforms gives it a robust understanding of cross-domain electromagnetic operations. GCAP will rely heavily on these competencies to maintain an advantage in contested areas dominated by anti-access and area denial networks. Sensor fusion is where Italy's influence becomes transformational. The program aims to create a unified architecture in which data from drones, satellites, surface sensors, and the fighter's own systems flow through a common combat cloud. Italy's strength lies in its development of open architecture systems that allow such modularity. Unlike more rigid industrial cultures in continental Europe, Italy has built an ecosystem around flexible integration. This approach aligns with the needs of Japan and the United Kingdom, both of which require export-friendly, configurable, and easily updated avionics that can respond to shifting operational demands. The benefits to Italy from assuming this leadership role are significant. Strategically, Italy gains autonomy within NATO by developing independent early warning and stealth countering capabilities. As the Mediterranean becomes more contested due to competition among Russia, Turkey, and North African actors, having a platform that can detect and classify stealthy threats will materially strengthen Italy's deterrent posture. From the perspective of alliance politics, Italy strengthens its hand by holding a technological niche that even major powers such as France and Germany lack within the European context. Industrial benefits are equally substantial. By leading the sensor pillar, Italy ensures that Leonardo will remain one of Europe's premier defense firms for decades. Advanced radar modules, infrared sensors, and electronic warfare components can be exported independently of the aircraft, opening the door to substantial revenue streams even in countries that do not buy GCAP. This modular approach mirrors the success Italy has already achieved with naval radars and surveillance systems. Moreover, the program guarantees long-term employment for Italy's high-skilled workforce in Turin, Venegono, and other industrial centers, reinforcing the country's technological base at a time when many European states are struggling to maintain defense industrial continuity. However, Italy's leadership in GCAP is not without challenges. Competition over work share remains an inherent risk in multinational projects. The United Kingdom and Japan both have ambitions to expand their electronic warfare capabilities, which may generate frictions if industrial boundaries become blurred. Italy must also maintain stable defense spending over the next 2 to 3 decades to avoid ceding influence within the program. Aligning industrial standards between Europe and Japan, particularly on cybersecurity and export regulations, will also require continuous diplomatic negotiation. Despite these challenges, GCAP represents a historic opportunity. Italy is not merely participating in another collaborative fighter program. It is shaping the sensory and information architecture of a platform that will guide Western air power strategy well into the second half of the century. For a nation that has long balanced between ambition and constraint, GCAP offers a rare moment of alignment between national capability, alliance needs, and global demand. By becoming the backbone of GCAP's sensors, Italy positions itself as a technological power whose influence extends far beyond its size, helping shape the future of air combat in both Europe and the Indo-Pacific.